Hello and welcome to this video. In this video, we will go through module contents of regular expression. So this module contains flags, constants, functions, and an exception. So we will first go through flags. So flag constants are, it is written that flag constants are now instances of regex flag. This is the class name, which is a subclass of enum.int flag. So the module is RE and the class name is regex flag. So it is a subclass of enum.int flag. So the first instance is re.a or re.ascii. So it makes the \w small and capital \b \d \s perform ASCII only matching instead of full Unicode matching. This is only meaningful for Unicode patterns and is ignored for byte patterns corresponding to the inline flag $A. So these flags are passed to the regex match or search function, as we will see later when we deal with functions. The U flag still exists for backward compatibility but is redundant in Python 3 since matches are Unicode by default for str patterns and Unicode matching isn't allowed for bytes patterns. Unicode and the inline flag $U are similarly redundant. re.debug display debug information about compiled expression, no corresponding inline flag. re.I or ignore case. So this will perform case insensitive matching. For ASCII, it will be A to Z and will match this expression like this will match all lowercase letters. Full Unicode matching for these symbols. I don't know how to read these accented symbols. Also work unless the ASCII flag is used to disable non-ASCII matches. The current locale does not change the effect of flags unless the locale flag is also used. This corresponds to the inline flag $I. Note that when the Unicode patterns A to Z or capital A to Z are used in combination with the ignore case flag, they will match the 52 ASCII letters and 4 additional non-ASCII letters. I with a dot, Latin capital letter I with dot above, Latin small letter dotless I, Latin small letter long S, and K, Kelvin sign. If the ASCII flag is used, only letters A to Z and capital A to Z are matched. re.l or locale, it makes \w small and capital and \b small and capital and case insensitive matching dependent on the current locale. This flag can be used to only with bytes pattern. It corresponds to the inline flag $L. This flag is discarded. Consider Unicode matching instead. The locale mechanism is very unreliable as it often handles one culture at a time and only works with 8-bit locales. Unicode matching is enabled by default for Unicode patterns and it is able to handle different locales and languages. re.m or multiline, when specified the pattern character caret matches at the beginning of the string and at the end of each line immediately following each new line, and then pattern character dollar matches at the end of the string and at the end of each line immediately preceding each new line. By default, caret matches only at the beginning of the string and dollar only at the string end of the string immediately before the new line, if any at the end of the string. Corresponds to the inline flag $M. re.no flag indicates no flag being applied. The value is 0. The flag may be used as default value for a function keyword argument or as a base value that will be conditionally odd with other flag. Example of use as a default value. So in myfunc, we have the flag as re.no flag and the match takes that flag argument. re.capital S or dot all makes the special character match any character at all, including new line. Without the flag, dot will match anything except a new line. The corresponding inline flag is $S. U or Unicode. In Python 3, Unicode characters are matched by default for str patterns. This flag is therefore redundant with no effect and is only kept for backward compatibility. See ASCII to restrict matching to ASCII characters instead. re.x or verbose. This flag allows you to write regular expression that looks nicer and are more readable by allowing you to visually separate logical sections of the pattern and add comments. White space within the pattern is ignored except when in a character class or when preceded by an unescaped backslash, or within the tokens like star, question mark, or question mark colon, or question mark p brackets and the capturing name. And for example, question mark colon, space colon and star question mark are not allowed. When a line contains a hash that is not in a character class and is not preceded by an unescaped backslash, all characters from the leftmost such hash through the end of the lines are ignored. This means that the two following regular expression objects that match a decimal number are functionally equal. So for example, here what we have done is we are compiling a regular expression here. So this is a raw string or triple quotes. Triple quotes are needed for multi-line strings. We have backslash d. That means it will match a digit. Plus means it will match one or more digits. Since it is multi-line and we have re.x, this space will not be counted. And then we have integral part and this space will not be also counted. Then we have backslash dot. So this will not be counted. And then we have backslash d star, that is 0 or more. So what this is basically capturing is any real number, that is a floating point number. Then we have functions. What functions we have with the regular expression module? So we have compile. It compiles a regular expression pattern into regular expression object, which can be used for matching using match or search and other methods described below. The expression behavior can be modified by specifying a flags value. Values can be any of the flags variables combined using bitwise OR operator. So the sequence goes like the prog variable is basically compiled version of regex, and result is equal to prog.match string is equivalent to result is equal to re.match pattern comma string. But using re.compile and saving the resulting regular expression object for use is more efficient when the expression will be used several times in a single program. Then we have re.search, which takes pattern, string, and flags, scan through the string looking for the first location where the regular expression pattern produces a match, and then return a corresponding match. Return none if no position in the string matches the pattern. Note that this is different from finding a zero length match at some point in the string. The expression behavior can be modified by specifying a flags value. Values can be any of the flags variable combined using bitwise OR. Then we have re.match. If 0 or more characters at the beginning of string match the regular expression pattern, return a corresponding match. Return none if the string does not match the pattern. Note that this is different from a zero length match. Note that even in multi-line mode, re.match will only match at the beginning of the string and not at the beginning of each line. If you want to locate a match anywhere in the string, you search instead of match. We'll see this search versus match. In fact, I think we should see this right now. So match checks only at the beginning of string, okay? And search matches anywhere in the string, and full match checks for the entire string to be matched. So for example, here C, if we take match, C is not at the beginning of string, so there is no match. But if we search C through A, B, C, D, E, F, we find a match. If we do a full match P dot star N Python, so it matches. And we also do R dot star N, then it won't match because R is not there in the full match. Okay, so this is the basic difference between search and match. Let's go back to this here. The expression behavior can, okay, we have read this. It's the same thing of the flags. Full match, the function we just saw. If the whole string matches the regular expression pattern, returns a corresponding match. Return none if the string does not match the pattern. Note that this is different from a zero length match. The expression variable can be modified, again the flags thing. re.split. Split string by occurrences of pattern. If capturing parentheses are used in pattern, then the text of all groups in the pattern are also returned as part of the resulting list. If max split is non-zero, at most max splits occur and the remainder of the string is returned as the final element of the list. For example, if we want to split this string words, comma, words, comma, words with capital W plus. Now, capital W is non-alphanumeric character. So, comma and space both will count as non-alphanumeric. So, the first element in the returning list would be words. Then this would be second. This would be third. And then finally, dot will also cause an empty string at the end. Now, if you want to group this, that is all the split values, then you will see that words, then comma, space, that is this will also come in the returning list. Then this will also come in the returning list, and dot and empty string at the end will be another one. But if you also supply max split is equal to 1, then it will split only once. So words will be 1, this words, and then this will be an entire second string will be second remainder of the string is the last element of the string. If you split on the basis of A to F plus, then it will be string at A and split at B. So 0, 3, 9 are three different elements in the returning list, and flags in this case is ignore case. So since we have given ignore case, the B in this character class will match the capital B. So I'm just trying to explain here. Now, if they are capturing groups in the separator and if it matches the start of the string, the result will start with an empty string. The same holds for the end of the string. That's what happened here. Okay, because the capturing groups actually here the capturing groups in the separator matches, then it will come as part of the string. So that's what the example same example is repeated here with a different string. We have triple dot here. So the first group would be empty string. Okay, here the empty string did not come because it matched words. Okay, but in here W plus does not match at the beginning of string, but here W plus matches at the beginning of string. So empty space will be the first element of the returning list, then triple dot, and finally at the end also there will be an empty string. That way separator components are always found at the same relative indices within the result list. Empty matches for the pattern split this string only when not adjacent to a previous empty match. So, for example, here we are splitting at word boundaries. Okay, backslash b means word boundaries. So the first will be empty string, and then we will have words, and then comma and space. Both will be both are word boundaries. So there will be the second, third element in the list, followed by word, then followed by comma, space, and then at the end there will be a dot. Okay. After dot, there is no word boundary, so the empty string will not be here. So similarly, other what you call other regular expressions can also be understood. Here, since we have used star instead of dots, we have got words uh, individually. Okay. A moment, please. We have re dot find all pattern comma string flags is equal to 0. Return all non-overlapping matches of pattern in string as a list of strings or tuples. The string is scanned left to right and matches are returned in the order found. Empty matches are included in the result. The result depends on the number of capturing groups in the pattern. If there are no groups, return a list of string matching the whole pattern. If there is exactly one group, return a list of string matching that group. If multiple groups are present, return a list of tuples of strings matching the groups. Non-capturing groups do not affect the form of the result. So we have here word boundary backslash b is there, f, and then a to z star. So this means it will try to find a word which begins with f. It is an English word which begins with f, and there should not be numbers here, and it should be a start with the word boundary, that is dot, space, comma, and those kind of things, exclamation mark. So the first word is which does not match. Then we have foot. Now foot matches because F will match the F after B, and A to Z star will match OOT. So foot is one. Then we have or will not match, hand will not match because both do not begin with F. Then we have FELL, which will match, and similarly fastest will match. So three values will be returned in the uh, returning list. And when we have the regular expression as W plus is equal to D plus, this is alphanumeric string with at least one character is equal to some number. So here we have set, but set is not, set will match W plus, but then there is space. The space will not match is equal to. So it will start looking again with W width. So width will match W plus and D plus will match 20 and is equal to this. So this is 1. But then these two are captured separately. W plus is captured separately and D plus is captured separately using parentheses. The first element of the list will be a tuple with two elements, width and 20. And similarly, height and 10 will be the second tuple in the returning list. The expression behavior can be modified. This is the same thing again. RE.findIter. Return an iterator yielding match objects over a non-overlapping matches for the RE pattern in string. The string is scanned left to right and matches are returned in the order found. Empty matches are included in the result. And then the same thing again about flags. RE.sub. Return the string obtained by replacing the leftmost non-overlapping occurrences of pattern in the string by the replacement tuple. So you have pattern, you have REPL, and you have string. So if the pattern matches, you replace it by replacement. If the pattern string isn't found, string is returned unchanged. REPL can be a string or a function. If it is a string, any backslash escapes in it are processed. That is, backslash n is converted to a single new line character, backslash r is converted to a carry return, and so forth. Unknown escapes of ASCII letters are reserved for future use and treated as errors. Other unknown escapes such as backslash ampersand are left alone. Back references such as backslash 6 are replaced with the substring matched by group in the pattern, for example. So if you look at this substitute, so pattern is def followed by one or more space. Then we have parenthesis. So this will match def followed by space, and this is the pattern group. Okay, this is not parenthesis. So this is the pattern group. So the first character should be A to Z, small a to Z or capital A to Z, and then can be underscore also. Okay, so all right, we'll see this in a second. So in the string, it will look for def. So def is matched in the string, and then space, and then M is part of A to Z. So it will match. So M has matched. And then we have A to Z or 0 to 9 underscore star. So this star means 0 or more. So my func will match here. Okay. Then we have backslash S star, 0 or more space. So this will match. And then we have backslash parenthesis, backslash S star, backslash right parenthesis. So basically this pattern is going to match def my func. Okay. And the colon is also there. So this will match this what you call string. And our replacement is static pi object star backslash n pi underscore and then backslash n pi underscore, and then we have backslash 1. So backslash 1 is what? Is this matched group. Okay. What is this match group? This is my func. So n pi underscore my func will be there, and then followed by void, followed by parenthesis, and then void, and then backslash n, and then left brace. So that is how this has worked. If REPL is a function, it is called for every non-overlapping occurrence of pattern. The function takes a single match argument and returns the replacement string. For example, if we have match object here, so match object dot group is equal to minus, return empty string, else return minus. Okay. So in this case, we have our pattern as minus 1 or 2. So minus 1 or 2 minuses are searched for, and then we have a dash replica here. So what happens here is, since we have to match 1 or 2, it will match 2 here. Now this matched object group will not match here with the single minus. It will match with double minus. So single minus is returned for this. So 2 minuses will be replaced by 1 minus, and therefore 4 minuses are replaced with 2 minus. Further, after program, there is a single minus. Okay. So this will match because least number is 1. So now we have returned empty space for this. So we have a space over here. Similarly, if you look at the second example, we have RE backslash S. That is we are looking for a space and space. So we are looking for a pattern called AND. Okay. We are looking for a pattern called and we have ignore case flag here, so it will match capital and small both. So this will match this much. The space before and the space before the space after and will also be matched. And what will be the replacement pattern? Space ampersand space. So our returning string becomes this. The and is replaced by ampersand. So all right, I was thinking something, but then that is not valid. The pattern may be a string or a pattern. The optional argument count is the maximum number of pattern occurrences to be replaced. Count must be a non-negative integer. If omitted or 0, all occurrences will be replaced. Empty matches for the pattern are replaced by only when not adjacent to a previous match. So sub x star minus abxd returns minus a minus b minus minus d minus. In string type REPL arguments, in addition to the character escapes and back references described above, backslash g name will use the substring matched by the group name as defined by the this name over here. Syntax. Backslash g number uses the corresponding group number. Backslash g2 is therefore equivalent to backslash 2, but it isn't ambiguous to replace in a replacement such as backslash g 20. Backslash 20 would be interpreted as a reference to group 20, not a reference to a group 2 followed by a literal character 0. The back reference backslash g0 substitutes in the entire substring matched by the RE. The expression again is the same thing, and sub n function performs the same operation as sub but returns a tuple new string number of substitutions made. RE.escape escapes special characters in pattern. This is useful if you want to match an ordinary literal string that may have regular expression meta characters in it. For example, RE.escape https://www.python.org. In this case, dots are meta characters. So if you escape, those will be escaped with \w. Then if you want to find legal characters, then string.ascii lowercases are literal characters, string.leads are valid characters, and then this string. So if you escape this, these will be escaped here. Okay. Then we have operators. So you have joined after mapping it to escape, and then operators are sorted. This function must not be used for the replacement string in sub and subn. Only backslashes should be skipped. For example, we have a regular expression pattern d plus, that is a number, and in the sample we have /user/sbin/sendmail minus 0 errors 12 warnings, and then we substitute digits re. This is our pattern, and we have to replace here digits underscore re is here, d plus dot replace backslash with r backslash. So in this case, what will happen is it will try to match the pattern. Okay, a pattern is 0 and 12, so those will match with d plus. So it replaces that with d plus. Okay. re.purge, it clears the regular expression cache. So the compile, whatever you have compiled using the compile call, it will clear that cache. Now we have one exception here. That exception is pattern error. Exception read when a string passed to one of the functions here is not valid regular expression. For example, it might contain unmatched parentheses, or when some other error occurs during compilation or matching. It is never an error if a string contains no match or a pattern. The pattern error instances following additional attributes: message, the error message, pattern is the actual pattern, position is the index in pattern where the compilation failed, line number, the line corresponding to position, and column number. So I think we will stop here, and one more video and we should be able to finish this. Okay. So I will finish this in the next video and then we will start looking at the examples. So I hope that you are enjoying the video, and this video was more, I believe, more explanatory in the nature because there were lots of examples which we have covered, and we will cover more and more examples. Okay. So stay tuned for more video on regular expressions. Thanks a lot for watching. Happy programming.